Okay, so we're going to start off with the warm-up. Turn to the warm-up section of your binder. If you've been in class with me, you have warm-up papers. If not, you're doing them on a sheet of lined paper. Please do the following 2 questions. Part A has got a few parts to it. And then pause the video and check back for your answers. Okay, we're going to go over the warm-up. So the square root of 128, we want to simplify that in terms of a perfect square. If we list out the factors of 128, 128 times 1, 64 times 2, and then we have 32 and 4, and we have, what else? Well, we can stop there because we already have a couple of perfect squares right here. 64 is a perfect square, 4 is a perfect square. And we said always use the largest perfect square. So we're going to use that 64. So the square root of 128 is equal to the square root of 64 times the square root of 2. And of course the square root of 64 is 8. And we'll leave that square root 2. Okay. Number 2, part A, what is the value of negative 1 squared? That's positive 1. Negative 1 cubed, that's negative 1. Negative 1 to the 4th, positive 1. Okay, for part D, and this is the important part that we're going to need later in the lesson, fill in the blank. The value of negative 1 to the n, where n is an integer, is equal to positive 1. So we got it equal to positive 1 here and here. If n is, so what you should notice about the exponents, and n here represents the exponent above the negative 1, negative 1 squared is positive 1, negative 1 to the 4th is also positive 1. So when the exponent is even, then we get positive 1, or over here, 3, the exponent is odd, we'll get negative 1. Okay, so if I want negative 1 to the 8th, negative 1 to the 9th, we could write out negative 1 times negative 1, 8 times. Or we can just notice that the exponent is even, so this is going to be positive 1. For negative 1 to the 9th, again, we could write out negative 1 9 times, but we don't want to do that. We want to use the patterns we observed above. So negative 1 to the 9th is going to be negative 1 because the exponent there is odd. Okay, let's get into today's lesson. So last time when we were simplifying radicals, we talked about radicals that have a negative inside the radical, or the radicand, and those involved I. Today we're going to talk about complex numbers, and a complex number is a mix of real and imaginary. Oops, let me fix that. So a complex number is a mix of a real number and an imaginary number. The general form of a complex number is a plus bi. A is the real part, and bi is the imaginary part. Okay? We want to do some operations on complex numbers. Addition, subtraction, multiplication, division, to see how they work. Okay, so the first thing, addition and subtraction of complex numbers. So to add or subtract complex numbers, combine the real part and combine the imaginary part. Okay, so negative 2 plus 6i plus negative 1 minus 3i. So the real part, negative 2 plus negative 1, that's just going to be negative 3, and 6i plus negative 3i. We'll add them like I was any variable, if it were x, y, whatever. So 6i plus negative 3i plus 3i. Number 2, 4 minus 6i minus negative 2 minus I. Remember, when you're subtracting, you're really adding the opposite. So I'm going to distribute through the subtraction sign. So it's going to be 4 minus 6i plus 2 plus I. And actually, we can get rid of this set of parentheses here. Okay. So the real part, 4 and 2, 6. The imaginary part, negative 6i plus I, negative 5i. Okay, number 3. 6 minus 6i. We'll distribute the subtraction, plus 5 plus 5i. Real part, 11. Imaginary part, negative 1i or negative I. Okay. Next, we want to look at powers of I. We know I is equal to square root negative 1. So if we want to find the value of I squared, we know I squared is I times I. So I times I is the square root of negative 1 times the square root of negative 1. And if we have two square roots of the same radicand, they both have negative 1 inside the radical, they cancel each other out, and this is just negative 1. So I squared is negative 1. I cubed, that's I squared times I. And I squared, we found before, is negative, I squared is negative 1. I is just I, so that's going to be negative I. I to the fourth is I squared times I squared. And we know from over here, I squared is negative 1. So I to the fourth is positive 1. Okay. So if we want to simplify higher powers of I, like I to the 41st, I'm going to rewrite this as I to the 41st is equal to I to the 40th times I. All right. And now I'm going to use one of these powers to simplify that further. So that's going to be I squared to the 20th times I, but I squared is negative 1 to the 20th times I. All right, now we're back to our even and odd powers of negative 1. For even powers of negative 1, we said they're equal to positive 1. So this is 1 times I, which will become I. All right, number 5. So we'll use I to the 59th is equal to I to the 58th times I. And that's going to be I squared to the 29th times I. And then if we substitute negative 1 for I squared, so it's going to be negative 1 to the 29th times I. So negative 1 to the 29th, we have an odd power of negative 1, which will be negative 1 times I. So this will simplify to negative I. All right, I to the 35th. Again, we're going to kind of break off one of the powers of I. We'll call it I to the 34th times I. So that's going to be I squared to the 17th power times I, which is negative 1 to the 17th times I. Again, we have an odd power of -1, which is just -1. And this is also -I. Okay. Multiplication of complex numbers works just like multiplication of real numbers, right? If you had x plus 4 times x plus 5, you distribute the x, right, and then distribute the 4. Same thing for complex numbers. All right, so if we're multiplying -2 plus 2i and -6 plus 4i, so we're going to distribute the -2, so that's 12 minus 8i, and now we'll distribute the 2i, so that's -12i, and then 2i times 4i plus 8i squared. Okay, and we have like terms over here. This is 12 minus 20i plus 8i squared. And our answer has a power of I, the I squared, which we know I squared is equal to -1. So if we substitute in -1 for I squared, that's going to be 12 minus 20i plus 8 times -1. So that's 12 minus 20i minus 8. And now if we add real part to real part, imaginary part to imaginary part, we'll have 4 minus 20i. Okay, number 8. So we'll distribute the 2. 8 minus 6i minus 8i plus, 6i squared. Like terms over there. So we have 8 plus 2i. And then we know I squared is -1 plus 6 times -1. And combining like terms, real to real, imaginary to imaginary, 8 and -6 is 2 plus 2i. Okay. Division of complex numbers. In order to divide complex numbers, we use something called the complex conjugate. So remember, our standard form of a complex number is a plus bi. The complex conjugate of a plus bi is a minus bi. So all we're doing for a complex conjugate is we're changing the sign in the middle. So to divide complex numbers, we're going to multiply entire fraction by the complex conjugate. Okay. All right, so let's take a look at how this works in number 9. Complex conjugate of denominator. Important detail. All right, so in number 9, the complex conjugate here is going to be -3 plus 2i. So the numerator is going to get a multiply by -3 plus 2i, as well as the denominator. Okay, and we'll simplify. We have 12i minus 8i squared over 9 minus 6i plus 6i minus 4i squared. Okay, cleaning up like terms and inserting, Okay, so combining like terms and inserting I squared is -1. So that'll be 12I minus 8 times -1 over, in the denominator, the middle terms will cancel. So we have 9 minus 4 times -1.
Please excuse the interruption. Mr. Burns, please report to the cafeteria. Mr. Burns, please report to the cafeteria.
So it's 12I plus 8 over 13. And remember, we want to write it in standard form. The real part comes first, so I'm just going to switch the order in the top. It'll be 8 plus 12I over 13. Okay, last one. So we said to divide complex numbers, we're going to multiply everything by the complex conjugate of the denominator. That'll be 3 minus 5I. All right, let's see what we get. So that's going to be -18 plus 30I minus 15I plus 25I squared over 9 minus 15I plus 15I minus 25I squared. Okay, so the numerator, we have -18, and then these combine to plus 15I, and we can substitute I squared with -1. The denominator, the middle terms will cancel, so we have 9 minus 25 and I squared, so we'll put in -1. Okay, cleaning up the numerator, -18, this will be -25, so that's -43 plus 15I over 34, okay? When you're dividing complex numbers, the denominator will always be real, right? We got 34 denominator in number 10, which is certainly a real number, and then 13 for our denominator in number 9, which is also a real number, okay?